Good morning students. Welcome to the video on integrated circuits. So in the previous videos we have discussed about the various fabrication process. We started with the silicon wafer and we have seen how to do or how to implement the various components inside the wafer to make it as a diode or to make it as a transistor. Now in this video we will be discussing about the integrated circuit. So what is meant by integrated circuit? From where it started and what are its advantages? So we know that in electronics, integrated circuit is nothing but it is a complex set of electronic components, and the interconnection of those components they will be imprinted or they will be imposed or diffused in a tiny slice of semiconductor material. The tiny slice of semiconductor material is normally a silicon wafer. So what we do is based on my requirement or based on my application, the various components like diodes and transistors are fabricated on a single wafer. So these are normally called as ICs, or we will be calling it as chips. So the integration of these various components into a smaller chip enables for the new application of electronics which was not possible in the discrete devices. So we know that practically for a mobile or if I take a watch, it is not possible to have a resistor or a capacitor independently or to be having it as a separate component. So the integration allowed the complex circuit consisting of millions of transistors, diodes, resistors and capacitors which can be included in a single chip which is of a size of in terms of centimeters. Now coming to the integrated circuit, because of this miniature in the size, this can be applied in various areas like mobile and in radar or satellite systems, in spacecraft, also in automation the industries. So we know that this system evolved from the vacuum tubes, and by the mid of the 20th century, the technology advancement in the semiconductor device fabrication is enormous. So, coming to the advantages of the integrated circuit, we know the only point is it is extremely small. We know that a single chip IC, a single chip, an IC of size of some 2 to 3 centimeter can have millions of transistors. We know about our various processors, high speed processors, and the GPUs and various components which will be having an enormous power. But the extreme small size has its own advantage. The first one is the small weight because of its miniature circuit. So the weight of the device becomes reduced, and also it becomes low cost because you can produce millions and hundreds of devices can be produced in a single process, and it is more reliable, and you can there is less possibility of error in the or variation in the output of the device because it is environmentally protected, and also it consumes less power and easy replacement because it is economical to replace the entire IC when compared to repair them. And the speed, because of the reduced spacing and because of its miniature size, the operating speed can be increased, and also there will be close match of components and temperature coefficient between the production in batches because almost all the processes are going to be similar. So here you can these devices can operate at very high temperature, and also it is possible for a small scale operation. Now, compared to coming to the disadvantages of integrated circuit, the main important thing is the individual component which is present inside the integrated circuit cannot be removed or it cannot be replaced, and also these devices cannot be applied for a very high power applications. So the limited power rating is there because we very high temperature will result in large amount of dissipation which may result in the burnout of the device. Also, it is not possible to fabricate the inductors and transformers. So the low temperature coefficient is difficult to be achieved, and also there are some concepts like the voltage dependence of the resistors and the capacitors. So now coming to the types of integrated circuit, integrated circuits can be classified as monolithic, thin and thick film ICs and hybrid ICs. Monolithic ICs is nothing but where we will be having a complete circuit inside on one silicon wafer. Normally, the example for it is ICs which is used that operates at microwave frequencies. So here the thick and thin film ICs are based on the process which is used to a process employed for the formation of the components and the metallic conduction patterns. So here, when I take the thick, thin film, it employs an evaporation or cathode spectrum, whereas thick film employs silk screen techniques. So these two methods are used either to this is both will be having the same application, but thin film is nothing but using an deposition material deposition process will be having a thin layer of it, whereas in thick film we'll be having the silk screen printing technique. And coming to the hybrid is nothing but where I will be having some components. It may be an active or a passive components like transistor, diodes, resistors, which will be placed on an PCB the same way as the monolithic integrated circuit. So based on my application, I can decide whether I will be going for a monolithic or hybrid applications. So here coming to the generations of my integration, the first one is small scale integration. So where the number of ICs or the number of transistors used in the circuit will be around in terms of hundreds. Medium scale integration is in terms of some 2000, 64 to 2000. So large scale integration is around 60,000 we will be having. So like this, we will be having very large scale integration as well as we will be having ultra scale integration techniques. So these various generations are nothing but the amount of transistors which is present in during the corresponding time. So we can see that it started with the tens of transistors in a gap of less than a lifetime of a human being. It has evolved to a very large scale integration, very large scale integration or ultra large scale integration, where 10 million components are incorporated inside a single IC. So the Moore's law states that the integration complexity of an IC doubles every 2 to 3 years. That is, we can see that the number of transistors which is present inside an IC, which can be accomplished in an IC, will be doubled for every 2 years. So we can see that in 1970s, the number of ICs which is present is around 2.25k, whereas in the same in the 2000 it is around 42 million transistors. And also this graph gives us the evolution of the processors. So it started with Intel processors, that is 4004 Intel 400, which is a 4-bit microprocessor, which is evolved into the 32-bit microprocessor, that is Pentium 4 processor, in the gap of 30 years. So we can see that the number of transistor doubles every 2.3 years, which is very high and the growth is very fast. So we can see also that the clock speed also doubles for every 2.16 years. That is when we go for a processor manufacturing, and the gate length is divided by every 2 year or by 2 for every 5.43 years. So in this video we have discussed about what is meant by integrated circuit, what is its evaluation, how it got evolved, and what are the different classification of ICs and its various generation. So in the next video we will be discussing about the CMOS fabrication process and the integration of other components. Thank you.